Okay, in this video we're going to have a look at sectors and arcs. I've got a question up here on the board which we'll have a look at in a minute. It's quite a tricky little question. But initially we need to have a think about what a sector and an arc, what they are. Well, essentially they're bits of a circle. And I'm going to draw a circle here. Freehand, that's not bad. Let's put the centre of that circle on there. And a sector and an arc are essentially the parts of a circle that are made when we just take out a chunk or a part of that circle by dividing it up with two radii. So we've got two radii there and a part of the circumference. And the circumference, or the part of the circumference, is our arc. And we've actually made two arcs here. If you think about it, we've got there a small arc, but we've got the rest of the circumference as well. And that's also an arc. And they have their own name. This one is called the minor arc, because it's the small one. I'm sure you can guess that the big one, therefore, is called the major arc. And the bit that we've got in here is our segment. It's like a slice of pizza. It's our segment. And we need a way of calculating these. And the formulae for these are usually given to you in formulae tables. And you'll see here I've written up a couple of formulae that I know you're going to recognise because they're just straight, simple ones to do with circles. One is the circumference and one is the area of a circle. It's easy to work out which is which when you look at the dimension r and you think this one is r squared, therefore that's going to be an area. And this one here just has no squared in there on the r, so that one is the circumference. So we don't actually want the whole circumference. We just want a little part of it. So what we need to do in order to work that out is think, well, how much of the circumference have we got? I'm going to focus on this minor arc here. How much of the circumference is that minor arc? Well, it depends how big that angle is. If that angle was 180 degrees and it was half of the circle, well, then you just take half of the circumference for your arc length. This one's a bit less. It looks to me like it's about 70 degrees. So we'd have a fraction here. And whatever that arc is, I'm going to call it theta, which is commonly used to describe an unknown angle. Basically, we're just saying we've got a fraction of our whole circumference, and I'm going to call it theta over 360. And that's the formula that is in your table, and that one gives you arc length. Pi r squared would give you the area of the whole circle. Just the same thing, I just want a fraction of it. I don't want the whole thing. And again, so I want, depending on how big my angle is, theta over 360 times pi r squared. And that one gives you the area of the sector. So, here's a typical question. It's in the context of manufacturing. And the question says, you're manufacturing these parts. I'm not sure what that would be a part of. Maybe it would be a part of a piece of cutting equipment or a blade or something like that. And essentially, it's forming part of a circle. If you imagined here, I continued around there, I could actually make one big circle. But I'm not dealing with all of that circle. I'm dealing only with a bit of it that's bounded here by this 40-degree angle. So I know from this, I don't want the whole area, this is the one I'm on. I'm going to want theta over 360, and my theta is going to be 40 degrees. And I could use that to work out what the area of that sector was. But actually, interestingly, I don't even want the whole area of that sector. I only actually want this bit. So I don't want anything here. That's all got to go. So the method I'm going to use is I'm going to work out the area of this sector. And I'm going to get rid of what I don't want. So I'm going to take away the area of this sector. Okay, so now we know what we're doing. We've got to start putting some numbers in. So let's have a look at that. The area of the big sector, first of all. Well, I've got my radius on here. The radius of that circle is 9. So the area of that whole circle would be given, let's just thing here, I'm going to be looking at the big, which I used pink for. Okay, this is my big sector. Radius is 9, so the area of the whole circle, if we continue that one round, would be pi times 9 squared, pi r squared. So that would be 81 pi. Circle equals pi r squared, which equals pi times by r is 9, square that is 81. So that equals 81 pi. And I'm going to leave it like that for now. But I don't want all of that. I've only got 40 degrees worth of that circle. 40 degrees out of a whole circle, which is 360 degrees. So the area of our big sector equals 40 over 360. This is the one I'm using. Times by the area of the circle, which was 81 pi. And now you just got a calculator job there. You had to put all that in. You might notice that 40 over 360 cancelled down. That's a ninth. A ninth of 81 would be 9. So actually, that would cancel down nicely to 9 pi. You could just put it all into your calculator as it goes. And if you want a decimal answer to that, you need to use your little button like this, which is S to D. On some calculators, it will look like this. That converts a fraction to a decimal or a surd to a decimal. And this actually is neither. It's an irrational number, but it will give you a decimal answer. And for that, it is 28.27. Let's give it some units, centimetres squared. Your calculator display would go on longer than that. I've put it to 2 decimal places. And I've done that because I've decided I'm going to give my answer to the overall question to 1 decimal place. So at this point of the question, I'm just keeping 1 extra degree of accuracy in my decimal places. So we now need to come on to the small sector. And it's exactly the same thing. The small circle is 5 pi r squared. So that's pi times by 5 squared, which equals 25 pi. So the small sector that equals, again, 40 over 360. If you remember, that cancels to a ninth. 1/9 times by 25 pi. Calculator job there once again, and that will return you an answer of 8.73. 8.73 centimetres squared. Well, we've done all the hard work now because what we were looking for was our green area, the area of that cutting implement. So, the area of the green, we've just got to take that one off here. So 28.27, subtract 8.73, That is going to give you an answer of 19, and I'm going to round my answer now, as I said, to 1 decimal place, 19.5 centimetres squared. And that's a pretty in-depth example of how you would apply these basic formulae for arc length and area of sectors to a more complicated example. You might actually see questions where you're just given a whole circle and you're just asked to work out the arc length or the area of a sector. Great, just jump straight for those. And here we've just had to use a little bit more thought and think, okay, we're taking one sector away from another to give us the area of that green shape.